Back now on the morning show, the wise guy Matt Sellon is here this morning talking turkey. Tell me about tryptophan.
Oh, tryptophan. Okay, well that's an interesting one. That's the stuff that's supposed to make you sleepy. And it does too, because it stimulates the production of ultimately serotonin, which is this neurochemical which kind of relaxes you and things like that. But it turns out, and turkey does contain tryptophan, but in order for tryptophan to have the effect that you really want, if you were to take it to relax yourself, you'd want to do it on an empty stomach without a lot of other proteins. And of course, when you're eating turkey, you're getting tons of proteins and your stomach isn't empty.
So everything you're eating is basically balancing it out. So it's not the tryptophan putting you to sleep.
It's not really the tryptophan so much, because the other things like chicken and cheese and all that contain tryptophan too. But it's really that you're eating a lot of food, and then when you're full like that, then it just takes a lot of energy for your body to digest it, and that's what really makes you tired. Plus, you tend to drink a little wine, you know, with dinner in the afternoon, and you're really stuffed, and then, you know, you don't really perhaps want to do the dishes, and so you just
you take a nap instead.
Right.
So now you can tell the family this, maybe. You can be a smarty. What else about turkey?
Okay, well, I wanted to talk about cooking time, because I think it's fascinating, and this has to do with physics, and it even has to do with Albert Einstein in a sort of sideways way, because Albert Einstein figured out diffusion to some extent, and heat goes through an object by diffusion, so it's very relevant to physics. And so the thing is, the question is, if you double the weight of a turkey, how much do you have to increase the cooking time by? Suppose you know that a 10-pound turkey takes 4 hours to cook. If you had a 20-pound turkey, how long do you cook it?
8?
No,
6?
not 8.
You tricked me with this last year. Is it 6?
I did too. No, it's about 6.5, and you can figure this out. Well, basically what you do is you stick a thermometer in it so you know what it's done.
Right.
Okay, so it's not that hard to do. But the thing is, if you, and I illustrate this with some sugar cubes here. If you have, here's this one sugar cube, right? And if I take sugar and I want to make it twice as big in every way that you could measure it, so you have, you know, twice as deep and twice as wide and twice as high, then you end up with 8 sugar cubes. Okay, so if you double the dimension of something, you increase the mass of that thing, the size of it, by 8. Okay? And so that means that if you want to just double the weight of something, so the weight depends on how much is there, then it's really just having 2 sugar cubes. And so how much bigger is that really? It's not a factor of 2 bigger. It's only about 25% bigger if you were to measure, you know, the size of the turkey.
Okay, all right.
And you can do this too. You can illustrate this with a balloon. If you just blow a balloon up, you know, take maybe 3 or 4 breaths and you blow it up, and then see how many more breaths you have to put in there until it's twice the size, and it's a lot more breaths. Okay. And so basically, you would think that, so maybe you only need to cook it 25% longer, but that's not true either. Okay. Because what happens is, heat diffuses through something, and the amount of time it takes for heat to diffuse through an object is proportional to the square of the size of the object. Okay. So when you do all the math, it turns out, roughly speaking, you would guess, just based on physics principles, that you would have to, if you double the weight, that you would have to double the cooking time by a factor of 2/3 power. Okay. So you would multiply the weight.
That's a lot of math.
You double. You take the number 2 and you put the exponent 2/3 up next to it, okay? And then you figure out, if you just do that, you see that it would go from 4 hours to about 6 1/3 hour, okay? And it turns out it's about 6.5 hours. So that's really the way you can estimate this thing, and it has to do with the fact that things grow much more rapidly when you increase their size. The weight increases very rapidly, like the cube of the size, and then the heat diffuses as the square of the time.
It's a lot of information to cram into 3 minutes, and that's all the time we have.
Oh my goodness, okay.
So certainly not enough time to cook a turkey, but you can figure out how long you should cook your turkey. Matt, thanks for being here today. Happy Thanksgiving.
Happy Thanksgiving to you. And everybody, use a thermometer.
Use a thermometer, that's the key. Our physics professor here says so. Matt Sellon, our wise guy this morning. If you have questions for Matt, you can send them in here. We'll be back.